Kepler 10b orbits one of the 150,000 stars that the spacecraft is monitoring between the constellations of Cygnus and Lyra. We aim our mosaic of 42 detectors there under the Swan's wing, just above the plane of the Milky Way galaxy. The star itself is very similar to our own Sun in temperature, mass, and size, but older, with an age of 11.9 billion years compared to the 4.5 billion years of our own Sun. It's a quiet star, slowly spinning, with a weak magnetic field and few of the sunspots that characterize our own Sun. The star is about 560 light-years from our solar system and one of the brighter stars that Kepler's monitoring. It was the first we identified as potentially harboring a very small transiting planet. The transits of the planet were first seen in July of 2009. 560 light-years. It occurred to me that when the light from this star began its journey toward Earth, European navigators were crossing the Atlantic Ocean for the first time in search of new horizons. Today we're still exploring, and our crow's nest is a space telescope called Kepler. One day, the oceans we cross will be the galaxy itself. But for now, we imagine the worlds we discover by putting all that we've learned from our observations and analyses into the fingers of artists. Here you see Kepler 10b as a scorched world, orbiting at a distance that's more than 20 times closer to its star than Mercury is to our own Sun. The daytime temperature is expected to be more than 2,500 degrees Fahrenheit, hotter than lava flows here on Earth. Intense radiation from the star has kept the planet from holding on to an atmosphere, but here we see flecks of silicates and iron that have boiled off a molten surface and are swept away by the stellar radiation, much like a comet's tail when its orbit brings it close to the Sun. Many years ago, before Kepler, our team built a robotic telescope at Lick Observatory to learn to do transit photometry. We called it the Vulcan telescope, named after the hypothetical planet that scientists in the 1800s thought might exist between the Sun and Mercury. A planet that might explain the small deviations in Mercury's orbit that were later explained with Einstein's theory of general relativity. Vulcan is the god of fire in Roman mythology, a name befitting of a world so close to the Sun. When I saw the artist's rendering of Kepler 10b for the first time, the thought that immediately came to my mind was that this is our planet Vulcan. We'd come full circle in our quest, and we know that we've only begun to imagine the possibilities.